Here's the key for the second derivative quiz. On page 1, we're beginning with the function y equals the sine of 3x, and we're asked to find its derivative. So we see that we have the sine of an inner function. We have a composite function here. So this is going to require the chain rule. All right, so when we find dy dx, we are going to derive the outer, and sine derives to cosine with respect to the inner. So we're going to keep the 3x, so cosine of 3x, and then we're going to multiply this by the derivative of the inner function, which is a 3. So we don't see any 3's at the end, so we can rewrite this. We can put the 3 up as a coefficient, so we have 3 cosine of 3x, and we can see therefore our answer is E. For problem number 2, we're now moving to implicit differentiation. We're given this curve right here, x squared plus xy is equal to 10, and we're asked to calculate what dy dx is equal to when x is equal to 2. All right, so we have to do implicit differentiation, so I'll do that over here. We have 3 terms. The first term is x squared. We're deriving with respect to x, so that will become 2x. We then see xy. That is a product, so we must use the product rule. X is the first term, so we derive it, it derives to 1, and then we multiply it by the second term, which is y. No dy dx because we did not derive the y term. Plus, now we keep the x term and we derive the y term, the second term. Y derives to 1 times dy dx, but I'm not going to write the 1. And this is equal to 0. Now at this point, we want to solve for dy dx. You can do a couple of things here. You could actually plug in values for x and y if you'd like, or you can solve for dy dx and then plug in the values, whatever you prefer. I'll move everything over here so that we end up having x dy dx on the left, and we have negative 2x minus y on the right. And then dividing by x, that tells us that dy dx is equal to the negative 2x minus y all over x. We're asked to find the value when x is equal to 2. So dy dx, and we have x equal to 2. So that means we have negative 4 minus something all over 2. Now the question is, what do we plug in for y? They don't give it to you, and they're expecting you to find it. Now what we know, remember, is that this is our original curve. And if x is 2, then we have 4 plus 2y is equal to 10. Right, which allows us to solve for y because we now see that 2y is equal to 6 and y is equal to 3. So when x is 2, y is 3. Right, they were requiring you to find that. We can now replace this y over here with a 3. So we end up having negative 4 minus 3, or negative 7, all over 2. So our answer is A. For the third problem, what's the slope of the line tangent to the curve? So we see all this, and we are singing the derivative song. All right, the derivative is the slope of the tangent to the curve at the point. All right, so this is asking us for the derivative, even though it's not specifically using that word. Okay, so implicit differentiation again. Y becomes dy dx. 2 derives to 0. X squared over 2 becomes 2x over 2. Now, some of you may be wondering, do I have to do a quotient rule here? No, you don't. You can think of this as 1/2 x squared. And the derivative of that will end up being 1/2 times 2x, or just x. So we have x minus, and then 2 is a coefficient, so it will stay. And then we see sine again. This time it's a sine of y. So we are doing a chain rule. Sine derives to cosine. Right? So we derive the outer with respect to the inner. And then we multiply by the derivative of the inner function. And the derivative of y is dy dx. All right, so we have 2 dy dx terms, so we're going to get them over onto the same side. So we already had this dy dx, and we're going to have to add 2 cosine y dy dx to move it over to the left. And that leaves this x right here all by itself on the right. We can now factor out dy dx. And when we do so, dy dx divided by itself is 1. 2 cosine y dy dx divided by dy dx is 2 cosine y, and that's equal to x. So move over here, dy dx will be x over the quantity 1 plus 2 cosine y. Okay, so now we just need to plug in, and by the way, you could have plugged in the values back here and just solved for dy dx in that regard. That's totally fine. Okay, so x is 2 and y is 0, so dy dx at 2, 0 is going to be 2 over 1 plus twice the cosine of 0. The cosine of 0 is 1, so this is 2 over 1 plus 2, or 2/3, so our answer is D. And then the final problem on page 1, more implicit differentiation. We're asked to find basically the same thing, except that we have quite an interesting function here. So there's a lot going on. Let's start by getting our derivative, because once again we see slope of the tangent to the curve, all right, and it's at a point. We are looking for the derivative here. All right, so y squared becomes 2y dy dx. And then we have this all to the third power. All right, so that is a chain rule. And it's a chain rule, and when it comes time to derive the inside, we see xy again, so that's product. So there's a lot going on here. Hopefully I have enough space. Okay, so 3 is, there's the cube, so that's going to come out front, and we now have xy plus 1 being squared. So we derive the outer with respect to the inner, and now we need to multiply this by the derivative of the inner function. So when we derive this, the plus 1 there, that's a constant, so that's going to derive to 0. So we're really not worrying about that. We have to focus on the product rule right here. And we actually did an xy product back with number 2. All right, so we derive the x and keep the y, plus now we keep the x and derive the y, and that's dy dx. And again, we see plus 1, that when we derive that, it goes to 0. So we derive the y squared, and then we use a chain rule. Derive the outer with respect to the inner times the derivative of the inner. Keep in mind that we have to derive both sides of the equation, and 0 derives to itself. Okay, so now we could solve this for dy dx. My recommendation, though, is actually to plug in at this point, which is what we could have done up here if we chose to. Once we got our derivative, we could have actually plugged in 2 for x and 0 for y and gone from there. So we could find this to be, get dy dx all by itself, but I think you're going to find it's easier if we don't. So watch what happens. We're going to make y equal to -1. So we have 2 times -1 dy dx plus 3, and then we have x times y, so x times y, 2 times -1 is -2, plus 1 squared, and then again y is -1, and then we have x is 2, and that's all equal to 0. Okay, so -2 dy dx plus, we got -2 plus 1 is -1. -1 squared is 1, so this is 3 times 1. So I don't have to write that one. And then we see -1 plus 2 dy dx. That's equal to 0. Let's distribute the 3. -2 dy dx minus 3 plus 6 dy dx is equal to 0. All right, again, I just distributed. The 3 can move over to the other side by addition. -2 dy dx's plus 6 dy dx's is 4 dy dx's. So dy dx will be 3/4. And again, our answer is D. There's a lot going on here. The implicits on the quiz will not be as bad as this, but if you've got these, then you're in good shape. All right, page 2 on another video.